In this video, we're gonna try to show the following. Given that A, B, and C are positive numbers, we want to prove that A over B plus C plus B over A plus C plus C over A plus B is greater or equal than 3 over 2. This inequality is very famous. It's called Nesbitt Inequality. And we're gonna prove it using algebra, just simple algebra. The key here to prove this result is to use the fact that for any x different from 0, we have that x plus 1 over x is greater or equal than 2. In this condition, we need to have x positive. So let's have x positive, strictly positive. Okay, in this case, x is bigger than 0, and we have x plus 1 over x is bigger than 2. So the key to solving this question is we need to find x and 1 over x. Okay, so I think it's easy to get 1 over x if we can find x and use this result here. Okay, here if we treat this one, if we can make this one look like an x, okay, we can manage to prove the result. Okay, here we have 3 different numbers, A, B, and C, and we see that we have these sums, A plus B, A plus C, B plus C. Okay, this is a cyclic or symmetric sum. Okay, and we see that if we can find one and prove the result, then we can do the same thing for the others. Okay, so one easy way to find x is try to write this one as some fraction of the sum of 2. So we have 3 numbers and we want to choose 2 different numbers from 3. That means we have 3 ways. Okay, so we can have the sums. We can have A plus B, or A plus C, or B plus C. And we're gonna modify this one in such a way that we have a ratio. So here, because we have A over B plus C. So the first thing is that we're gonna have this one over this one. So if we call x A plus B over A plus C, then clearly 1 over x is gonna be A plus C over A plus B. And since these 2 are positive, we're gonna have this result here. So we're gonna have this one bigger than 2. So let's do this. So here, if we use x, okay, for this one, so we're gonna have A plus B over A plus C plus 1 over x. This will give me A plus C over A plus B is greater or equal than 2. Note that x is this one. I'm using this result here that we have proved before. Okay, so now I proved this one here. So I can use the same thing. I can form another x with A plus B over B plus C. Okay, and I can have A plus B over B plus C plus B plus C over A plus B is bigger than 2. And the last one is A plus C over B plus C plus B plus C over A plus C is bigger than 2. Okay, so now I have 3 quantities. Okay, so if I add these quantities, okay, on the right side I'm gonna have something bigger than 6. Okay, 2 plus 2 plus 2. So I'm gonna add them side by side. Okay, so once I do the side-by-side addition, I need to show this one here. I need to get this one here in somehow. Okay, so that's why I'm gonna split this one here. So for this one, I'm gonna use A over A plus C, and also I'm gonna get the A over A plus C from something here. A over, what is A plus C? I should have A plus C somewhere here. So I'm gonna have here. So I'm gonna have B. Okay. If I wanna have B, I'm gonna have 2 B's. Okay. So if I add these 2, I'm gonna have 2B. Let me do this. So I'm gonna have 2B over A plus C plus. So here, plus what? Plus A plus B plus plus A plus C over A plus C, which is 1. So I'm gonna have 2B plus 1. Okay, I hope that you're gonna see this one. So if I add this one here, these 2, So I'm gonna have a plus c over a plus c, which is 1, and b over a plus c plus b over a plus c, which is 2b over a plus c. Okay, so this one will give me this result here, and I see that the same thing here. Okay, it's gonna work for the other two. So here I'm gonna get 2a over b plus c plus b plus c, no, here. So let me do b plus c. I need to do it with this one. So here I'm gonna have 2a over b plus c plus b plus c over b plus c, which is 1. So I'm gonna have 2a over b plus c. So plus 2a over b plus c plus 1. And finally, the same thing that you're gonna see, I'm gonna have 2c over a plus b plus 1. Okay. So this one, I'll take this one here. I factor by 2. I'm gonna have a over b plus c plus b over a plus c plus c over a plus b plus 3 is bigger than 6. Okay, so I add minus 3 to both sides and divide by 2. I'm gonna have a over b plus c plus b over a plus c plus c over a plus b is bigger than 3 over 2. So I'm using some simple algebra. I don't wanna. I didn't write all the steps, but you see them clearly. Okay, just use this one here. The key idea here is that x is positive. Okay, so we have to form this combination of two elements from 3. So we can do that in 3 ways. So we can have a plus b, a plus c, b plus c. And after that, we see that we can form this ratio here if we add this one here over this. We're gonna have a plus b over a plus c, and to get the 1 over x, which is the other ratio here, so I'm gonna have a plus c over a plus b, and now if I call this one x, this is bigger than 2. So this is what I use here, and I'm gonna do the same thing for the other ratios. Okay, so once I do the ratios, I'm gonna add side by side. So I'm gonna have 6, so 2 plus 2 plus 2, this is right side, and on the left side I'm gonna be smart. Okay, so here I'm gonna notice that I have here the same denominator. So here a plus b over a plus c, I have a plus c. So when I add, I'm gonna have 2b over a plus c plus a plus c over a plus c, which is 1. So that's what I get here. I do the same thing for the other ones, like this one here, which one I did second, b plus c, these two, I add these two, I'm gonna have 2a over b plus c and b plus c over b plus c, which is 1. So I do the same thing. Okay, and once I do, I factor by 2 and I add the 3, and after that I subtract it from the other side to get 3 over 2. So this is algebra. Okay, the only thing that requires some work is this result here. It's proved in the one of the videos, and if you are not convinced, since x here, so here let me write it down one more time. So x plus 1 over x is bigger than 2. X is positive. If you are not convinced, since x is positive, you can multiply both sides by x. You get x squared plus 1 is bigger than 2x. Okay, so now add minus 2x to both sides. You get x squared minus 2x plus 1 bigger than 0. And after that, we notice, what's this one? This is completing the square. We get x minus 1 squared is bigger than 0, which is always true. Okay, or if you are not convinced, you can start from here. This is always true because the square of any number is always positive, except when we have the 0 problem. So with the 0 problem is we don't have it because x is bigger than 0. So we can divide. We can have 1 over x without worrying about 0 because here x is bigger than 0. So start from here, go here, you get x squared minus 2x plus 1. Divide everything by x, you get this one here, and that's what you have to prove. Now, once we prove this result here, we have to use it. And to use it, we need to choose which x we're gonna use from the A and B and C to get this result here.